All right, last one on this set. I know these are a lot of problems. The more you practice, I know they're hard. The more you practice, the better you get, basically. The quickest route, Jane, is 2 miles offshore. Let's get a little color coding here. So we got, I don't know, we'll call this the water out here. So we'll call this the shore, I guess. So she's out here. She's 2 miles offshore in some little boat. Here's her boat. And when we say she's 2 miles offshore, we mean straight distance to the shore is 2 miles. She wishes to reach a village 6 miles down a straight shoreline. I know sometimes it's hard to envision all this. So we got this little village down here, which is 6 miles down the shoreline. She can row at 2 miles per hour. She can walk at 5 miles per hour. Where does she land her boat to get to the village in the fastest possible time? Sure, everyone's concerned when they're rowing, right? Doing a little calculus, trying to figure out where to go. So the idea here is we're just going to draw a general trip for her. Like, I don't know where the answer is, so I'm just going to guess, hey, look, I'm going to guess it's right there. Boom. Let's just say it's there. Notice she walks faster than she rows, so we probably want her walking as much as possible, right? So we don't want to shoot her way down by the house or the town. We want to get her a little closer here. It could be straight to the shore for sure. But the math will do that for us, right? That's an endpoint, so the math will do that for us. So envision that she's going to row to there, and then she's going to walk to there. All righty. I'm just going to call that distance x right there. You can call the other distance x also. Just makes the algebra a little different, probably a little harder. That means this red line here is going to be 6 minus x. You could have called the red line x, but here's the thing. This is going to wind up being the square root of x squared plus 4. If you called the other part, let me just do this in a little different color so you can see the orange here. Just if you called this x here, this would then be 6 minus x here. And then this would be square root of 6 minus x squared plus 4. So you can see that derivative is going to be a little trickier. It's not impossible, but I would stay away from that. Remember, we got a little formula that says distance equals rate times time. We're trying to minimize the time here. So time is distance divided by rate. So we're trying to minimize time. So the time is the time rowing plus the time walking. So the time rowing, both their times are just their distances divided by their rates, right? So the rowing distance is square root of x squared plus 4, and the rowing rate was 2 miles per hour. And then the time walking is the distance walking, which is that 6 minus x, divided by the rate walking, which is 5. So this is the total time. So again, all that picture, you actually did a problem like this in Trig Honors in that book. I remember one just like this. Don't know if you remember it or not. Like chapter 1. So it would have been way back to me when you learned how to use your calculator, I think. So this is my formula for what we're trying to minimize, which means I need to take a derivative. So let's see, we have a little chain rule here. 1/2 times x squared plus 4 to the negative 1/2 times the derivative of what's inside that thing, which is 2x. That 2 is still floating around there. It's just a constant. Plus, there's two ways to do this. You can do a quotient rule, but notice I'm just going to break this up. Be 6/5 minus 1/5 x, right? So then when I take the derivative, that derivative is just 0. And then the derivative of this is just negative 1/5. All righty. So we're going to set this equal to 0. We're going to do a little simplifying here. Let's see, that 1/2 and that 2 is going to be gone. So I still got a 1/2. So I got a 1/2 x. And then I guess I'll just write it like this, x squared plus 4 to the negative 1/2. I got a little different algebra, so we're going to set that equal to 1/5, and we're just going to start solving. So let's see. We'll go x times x squared plus 4 to the negative 1/2. I'm going to multiply both sides by 2. So we get 2/5. I should have actually maybe divided by x. I don't know if it would have been easier. Yeah, so I'm going to write it like this so you can see it better. X over the square root of x squared plus 4. What I'm going to do is just square both sides. I could cross multiply. There's lots of different ways to do it. I mean, let's cross multiply just for fun. How about that? 2 times the square of x squared. Now I'm going to square both sides. 25x squared equals 2. No, not 2, but 4 times x squared plus 4 25x squared equals 4x squared plus 16. We'll go over here. 21x squared equals 16. X squared equals 16 over 21. So x is the square root of 16 over 21. So we'll go 16 just so we can see a number. Square root of that number is 0.87. So remember my original picture. There's my x, right? So I guess the answer to the question is this is 0.87. I guess how do you say this? This would be 6 minus 0.87, right? Which is 5.13. I guess you'd probably say she wants to row to a point that's 5.13 miles from the shore. At this point, trying to answer that question, the perfect wording is a little bit weird. If you just had the x equals 0.87, probably be good. Let me just check it to make sure it is the right answer. Since I haven't done it, oh, look at that, 0.87, I got it right, which is always good. So I would probably say she'd row 5.13 miles from the town because it's a little hard to say where is that 0.87, but it doesn't really matter. So hopefully you saw some of those. Hopefully that helped a little bit. We'll have time to go over more in class. That's it for now.